Today we will start the second chapter, that is conservation laws and properties of space and time. Conservation laws and properties of space and time. This is our second chapter. You have already learnt or know the conservation laws. You all know that there are three conservation laws or basic laws. First one is law of conservation of linear momentum, and second one is law of conservation of angular momentum, and third one is law of conservation of energy. So from the heading of this chapter, it is clear that we will prove conservation laws. That is, we will prove the three laws by using the properties of space and time. So we can draw these laws from space and time. How can we deduce these laws from space and time? So there is correlation between space and time and conservation laws. So first of all, we know that there is symmetry in space and time. So on the basis of symmetry, we will prove conservation laws. So we may write it as, first of all, there is symmetry. If there is symmetry, symmetry means uniformity or equalness. It gives invariance. Invariance, that is, anything which does not vary. Invariance means which do not vary, which further give rise to conservation laws. So on the basis of this concept, symmetry gives us invariance, and invariance further gives us conservation laws. So we will prove these laws by this formula or this concept. So first of all, we have to study space and time. Space and time. We know that space is the surrounding around the earth and time is the duration or variation. So we will study first of all the properties of space. First article is properties of space. All you know that the space has different properties. So I will study the five properties, main properties of space. First of all, the space is three-dimensional. You know that there are three dimensions or three coordinates, x, y, z, or r, theta, phi, are used to describe the position of the particle in space. That is, x-axis, it is y-axis, it is z-axis, and this one is the point P. P is x, y, z, or in polar system it is r, theta, phi. So we can describe any point in the space by three parameters or three components. So we can say that space is three-dimensional. Second one, space is Euclidean. Space is Euclidean. What is Euclidean? You already know the Euclidean space. The space is said to be Euclidean if it satisfies the following conditions, that is, the shortest path between any 2 points is always straight line, and second one, sum of three angles of a triangle is always 180 degree. And third one, the Pythagoras theorem must remains good or hold good for a right angle triangle. And fourth one is the ratio of circumference to the diameter of a circle is always pi or constant. So, we can say that this Euclidean means flat or flatness. So, we can also say that the space is flat. Flat means which has no boundary, it is boundaryless or limitless, space is open. So, if space is open, it has no boundary, then the point drawn on the space, that is A to B, it is always straight line. If space is not flat, it means it is curved in nature. If it is curved in nature, then this is curved, then draw any 2 points A and B on the curve. It can never be straight line, it is always an arc. But our space is flat or Euclidean, it means the shortest distance between 2 points is always straight line. So, it is right, it is not flat, it is specially for bounded, not flatness. So, in this way, if we draw a triangle, any triangle PQR, we know that the sum of all the angles of a triangle is always 180 degree. But if space is not flat, then this triangle just like this one, P, Q and R, and this angle, these angles, sum of these angles can never be 180 degree if space is not flat. But we know that space is flat, it means the sum of all angles of a triangle is always 180 degree, this one. Our third property is the Pythagoras theorem holds good. Again, Pythagoras theorem means right angle triangle. So, we know that one angle is 90 degree, the sum of other two angles are also 90 degree, and net sum is 180 degree. So, it also remains good, hold good only in if the space is Euclidean or space is flat. And fourth one, the ratio of circumference to the diameter of a circle. If it is circle, then this is the circumference and this one is the diameter. If we find the ratio between the circumference and diameter, so this ratio is always constant. Circumference to the diameter is always constant, that is pi. So, these properties hold good if the space is flat. The second property is flatness or the space is flat. Next, third property, space is homogeneous. Third one, space is homogeneous. You know that homogeneous means constant or uniform proportion. So, we know that space is always homogeneous, that is the mixture of the gases at one place or the other place, it is always constant or the homogeneity is there in the space. So, it is also called the translational invariance. Translational invariance. So, this homogeneity is also called translational invariance. So, what is translational? That is a motion in a straight line. Invariance means it does not vary, invariance is constant. So, properties of space, if we move from one point to other point in a straight line, that translation means if we move from one point to other point in a straight line, then the property of space remain same at all the points. It means the property can never be changed with the movement along a straight line. So, you also observe that when we move in the space from one point to other point, the property of space at this point, A point, must be same as property of space at B point. This is called homogeneity. So, this third property. Next, fourth property, the space is isotropic. Space is isotropic. You know that isotropy means the properties of space remains same in all direction. Isotropy means in all directions. Homogeneity means in one direction. In one direction means translational. Isotropy means in rotation. In all direction means rotation. So if we rotate from one point to again reach at the same point on rotation, then properties of space at this point, at this point, at this point, it means the property of space at all points which are lying in the circle are always constant. So this is called isotropy of space. So we can say that this isotropy is rotational invariance. Invariance. As we know, translational invariance is called homogeneity and rotational invariance is called isotropy. Means property of space remains same then in a circle or in all directions. Next fifth one is the properties of space remain same on reflection. On reflection. Reflection. What is reflection? That is mirror image, just like as. So we know that if one point is lying at A, then the other point on the other side it is at B. If it is like as a mirror, then we can say that this B is the mirror image of A. So we can say that B, what is B? B is nothing, it is mirror image of A. When it is image? When we put or place a mirror at midpoint. So in space, every point is the mirror image of every other point in space. Let us say one point, this here is lying here and other point is lying here. So this image, this point is the mirror image of this point, or this point is a mirror image of other point. So every point in the space are mirror image of other point. So this is called reflection property. So if the coordinates of this A point are x, y, z, then coordinates of B points are minus x, minus y and minus z, means the values are same but with negative sign. So these are 5 properties of space. So similarly, we will study the properties of time. Second part, properties of time. The second part. So what are the properties of time? Just like a space, time also have some properties, but there are 3 properties. That is, first, time is one dimensional. It is one dimensional. As we know, in case of space, the space is 3 dimensional and but the time is one dimensional, because it moves in one side or it flow in one side. It move always forward direction, not in backward. That is one side, one dimensional. And second one, the space is homogeneous. Time is homogeneous. That is homogeneity. That is the time interval between any 2 events at any point is always same today as well as after 1 month or after 2 months, 1 year and 100 years. The time is passing, but the time interval between any 2 events is always constant. It means time is homogeneous. The time interval is always constant. That is homogeneity of time. This is second property. And third property of time is isotropy. So time is also isotropic. Isotropic. It means it does not change with the direction. That is isotropy. So these are 3 properties of time: one dimensional, homogeneity or homogeneous, and isotropic or isotropy. Now we will deduce the basic laws or conservation laws by using these properties of space and time. So, we will discuss in our next lecture. Okay, how can we prove this conservation law of linear momentum, angular momentum and energy from the properties of space and time. Thank you very much.